Alright, good morning or good afternoon and welcome to lesson 2 of module 1. Today we're going to learn a few new rules with exponents, specifically what do we do when we are multiplying numbers written in exponential notation that have the same base, or dividing numbers written in exponential notation that have the same base. Okay, so we'll go ahead and get into that right now. By the end of the lesson, you'll know you're successful if you know how to divide and multiply numbers that have the same base and are written in exponential notation. Let's get started. All right, we're going to jump right into our rule that we are learning today, or part of our rule. We're going to do the multiplication part first. So basically it says, in general, if x is any number, so if our base is any number, and m and n, the exponents, are positive numbers, then if we are multiplying these two things together, we just add those exponents up. Okay? And I'll show you with the new real number below. I want you to write the same thing. So say that x is actually a 5. Okay? And let's say it's being raised to the second power. Okay? And if we were going to multiply it by another base of 5, but with a different power, maybe 3, then to simplify this out, this is actually the same as saying 5 to the 2 plus 3 to the 5th power. Okay? And I'll prove it to you below. So 5 to the second power is the same as saying 5 times 5, right? And then 5 to the third power is the same as saying 5 times 5 times 5, right? And so this is the same as saying 5 times itself 5 times. We're just doing a little shortcut here, okay? So again, when you have the same base and you are multiplying numbers written in exponential notation, to simplify it, you just add those exponents up. Okay? Again, only when you are multiplying, though. All right, so this is the first rule we're going to learn and practice today. Let's go ahead and get started practicing this on the next page. All right, I'm going to start you off with a couple of these, and then you're just going to continue and get them all done on your own. For exercise 1, I have the same base. I'm multiplying these two numbers, so this is the same as saying 14 to the, 23 plus 8, 23, 24, 25, 26, 27, 28, 29, 30, 31. 14 to the 31st power. I just added my exponents up. Okay, kept the same base. I'll do one that is not a number. I'll do exercise 7 for you. So we have a b to the 94th times b to the 78th. This is the same as saying b to the, well, I need to add up 94 and 78. 8 plus 4 is 12, 9 plus 1 is 10, plus 7, 172. Okay? Please take a moment and go ahead and go through and do the rest of these, and then we'll go over them in about 1 minute. About 30 more seconds. All right, let's go ahead and start with exercise 2. So exercise 2, from yesterday's lesson, we remember that we need to keep that base in parentheses. It is important to do that. The exponent is going to the negative sign as well. And then we're doing 10 plus 13. This is 23. Exercise 3, 5, 78 plus 94. You can do this in your calculator too, guys. I'm going to do it in my calculator just for the sake of time. 94 plus 78 equals 172. I actually did the same number off to the side over there. Exercise 4, we have a negative 3 as our base, and we're doing this to the 14th power. Exercise 5, you had an a as your base, and you're doing 23 plus 8. This is 31. Exercise 6, f to the 23rd power. We did 7 together. And then we have exercise 8. It says, let x be a positive integer. If negative 3 to the 9th times negative 3 to the x power equals negative 3 to the 14th. What could that x be? So essentially it's saying that we need to find the difference between 14 and 9 to get this answer, right? We can fill in the blanks because 9 plus this x equals 14. So 9 plus this x has to equal 14. How can we find the x? Simple. Just subtract 9 from both sides, right? Find the difference. X equals 14 take away 9 is 5. So x in this case equals 5. And you can check it. Is 9 plus 5 14? It is. All right, let me know if you have any questions here on this slide before we move to the next page. All right, so just to check in with our success criteria, we're just going to go over the new learning we just did. If two numbers written in exponential notation have the same base, so let's do negative 1 to the 3rd and negative 1 to the 8th, and we are multiplying them, we simply add the exponents. Okay, that is what we have learned so far. Let's continue on. All right, using that rule, what would happen if there were more terms with the same base? Well, we would just do the same thing. So write an equivalent expression for each problem. Go ahead and do these two very quickly, and then we will go over them together. All right, for exercise 9, we have the same base, so we're keeping that base, and we're multiplying all these, so we are just going to add our exponents. 4 plus 6 is 10, plus 13 is 23. That's what you should have got there. And then for exercise 10, we have the same base being multiplied. We're keeping that base, and we're just adding these exponents. 3 plus 5 is 8. 8 plus 7 is 15. 15 plus 9 is 24. That's what you should have got here. 3 plus 5 plus 7 plus 9 should be 24. Make sure you have this down. Let me know if you have any questions before we move on. And yeah, it's a pretty simple lesson, straightforward today. Okay. All right, we're getting to a little bit deeper learning here. It says, can the following expressions be written in a simpler form? So remember, in math, our biggest goal is to just make everything as simplified as possible. That is what algebra is. So if so, it says to write an equivalent expression. If not, explain why not. So looking at exercise 11, we have 6 to the 5th times 4 to the 9th times 4 to the 3rd times 6 to the 14th. So a few things here I want to remind you of. Order does not matter when we multiply. So we can actually group these so that we are multiplying the same bases together first, and then the other two bases that are the same second. All right, so we can simplify this one right here. 6 to the 5th power times 6 to the 14th power, we can change that to just have one base. So that is the same as saying 6 to the, well, what's 5 plus 14? This is 19. Okay, and then 4 to the 9th times 4 to the 3rd, that's the same as saying 4 to the, well, what's 9 plus 3? 9, 10, 11, 12. So this is 4 to the 12th power. So we simplified that, okay? Now I want you to go through and try to simplify the rest of these. If you can't simplify it, explain to me why you cannot. So take maybe 2 minutes to go through these exercises and simplify them. I suggest highlighting, like I did, the two terms we could combine. Just keeps you more organized. Okay? All right, let's go through and start checking these. You'll see that I did some highlighting here to kind of separate my bases that were the same from my bases that were different. For exercise 12, I have a -4 in yellow being raised to the second power and a -4 being raised to the third power. I can combine those and write them with one base only. This is the same as saying -4, keep your parentheses, to the fifth power. And then my 17s, I can also combine those. Those are the same as 17 to the, what's 5 plus 7? 12. Okay, check that off. Make sure you got it down. Let me know if you have any questions about it. Exercise 13. I have 15 to the second and 15 to nothing. Well, is there really nothing there? What's invisible that is right here with this 15? There's an invisible 1. Cannot forget about that invisible 1 because you have to add it up, okay? So 15 to the second power times 15 to the first power, keep our base, 2 plus 1 is 3. And then we do our 7s. 7 to the second plus, or times 7 to the fourth is the same as 7 to the sixth power. All right. Now moving on to the exercises on the right side. These ones are a little bit different. So this is actually what we're going to be moving into eventually when it comes to exponential work. So it starts off with this, and it says 2 to the fourth times 8 to the second. Okay? And what they have done is they said, you know what? I can rewrite 8 to the second with a base of 2. 8 to the second power is the same as 2 to the sixth power. And so they rewrote it here. And now that we have it like this, can we simplify it even further? Well, yeah, we can. 2 to the fourth times 2 to the sixth, they have the same base now. And all we have to do is add those exponents together. So this is the same as 2 to the 10th. And again, their step was first, turn this into the same base as this. And then we can add our exponents and simplify it. Okay? And we'll learn more about how to do that later on in this unit. Okay, so the same thing they did here. They took this, 3 to the 7th times 3 to the 9th. They said, 3 to the 7th times 9. They said, 9, that's the same as 3 to the 2nd. So now they have the same base. We can simplify them. 3 to the 7th times 3 to the 2nd is the same as 3 to the 9th. Okay? And then this last one we have down here, 5 to the 4th times 2 to the 11th. Those do not have the same base, and we can't do what they've done in these two right here, because 5 to the 4th and 2 to the 11th, there's no way we can rewrite those so that they do have the same base. So no, they don't have the same base. They don't have and can't have the same base. We need the same base in order to simplify. Okay? Let me know if you have any questions here before we move on. If you struggle with these two, that's okay. We'll get into it later on in this unit and we'll practice a little bit more. For right now, just make sure you definitely have this part over here solidified and down. Let's continue. All right, moving into a little bit more practice where we're getting these more complicated numbers here. So it says, let x be a number. Rewrite the expression in a simpler form. So we're doing 2 times x to the third times 17 times x to the 7th. One thing I like to do is I like to just expand my number sentences like this so that I can see every part being multiplied. So I'm doing 2 times x to the third times 17 times x to the 7th. And the reason why I can break that apart and take apart the parentheses is because we're just multiplying, and order does not matter when we multiply. All right? Now I can simplify this. Can I do what 2 times 17 is and just write that as a number? Yeah. What is 2 times 17? Well, 2 times 17 is 34. So I'm going to go ahead and combine those together. This is 34. And then can I do x to the third times x to the 7th and simplify that? Yeah, that's what we've learned today. We can change that to be x to the 10th. And again, we were multiplying everything here, so we're going to keep multiplying it. And then I'm just going to rewrite this how they gave it to me initially, where they're right beside each other. 34x to the 10th. We don't need a parentheses or multiplication sign there because they can be directly beside each other and it will still mean to multiply. Okay, that's as simple as we can get it. It says, let A and B be numbers. Use the distributive law to rewrite the expression in a simpler form. So we're going to do A times A and A times B. So A times A is the same as A. Actually, I'll just write it out first. A times A plus A times B. All right? And we should know that A times A, this is the same as saying A squared. And then A times B, we can't combine those, but we can just write it as AB. Okay? And the reason why we can't combine any more is because these are being added together. They're not being multiplied. So that is as simple as we can get A squared plus AB. All right, let's move on to the next screen. All right, we're going to do the same thing here as well. We're going to distribute this. So we have B times A. We keep our plus sign in the middle. And we're doing B times B. Well, B times A, this can just only simplify to be BA, B times A. And then B times B, this is the same as B squared. So this is our final answer here. That's as simple as we can make it. We can't do anything else to combine there. And then exercise 20, it says use the distributive law to rewrite the expression in a simpler form. So we've very rarely done distribution where we have two things we're multiplying. But you do this thing, and you'll learn it in high school, called FOIL. And if you don't figure it out right now, don't freak out. FOIL. FOIL means first. So we're going to multiply our first numbers together. A times A. Okay. Keep our plus sign. O means outside. So we're going to do our outside. 0 to outside plus A times B. Okay. I means inside. So we're going to do our 2 inside. Plus B times A. And then L means last. So we're going to do our 2 last numbers, B and B. Okay. And again, you will learn how to do this later on in high school. But we're going to simplify it real quick. All right, A times A, this is the same as saying A squared. A times B, this is the same as saying AB. B times A, that's the same as saying A or BA. And then B times B, that's the same as saying B squared. Okay? There is an additional step we can do here. AB and BA, these are the same thing. So remember, order doesn't matter when we multiply. So it's AB and another AB. This is the same as saying 2 ABs. And then we just keep everything else the same. A squared plus 2AB plus B squared. All right, and again, if this is too difficult for you, that is completely fine. Don't worry about it. All right, moving on. All right, we're now moving into our second part of the lesson where we are no longer multiplying exponents with the same base. We are dividing them. So when we multiplied, we added our 2 exponents together. When we divide, we subtract them. So if x is a number, we have the same base and we're dividing. Remember, fraction sign means divide. We just subtract those exponents. M take away n. All right? Let's start with exercise 21 and we'll talk about it a little bit better. So 7 to the 9th divided by 7 to the 6th. This is the same as saying 7 to the 9 minus 6 third. Okay, again, you just subtract your exponents. I'll do exercise 23 with you. We have 8 to the 5th, we have 8 fifths to the 9th divided by 8 fifths to the 2nd. Well, we keep our same base. Remember, keep it in parentheses. It's important. And then we're doing 9 minus 2. 9, 8, 7. Okay, do these 2 on the bottom, please, and then we'll check them in 1 minute. All right, please check them with me. This stays a negative 5, and we keep it in parentheses. And 16 take away 7, this gives us 9. Right? And then the one over to the right, 24. We have 13 to the, what's 5 take away 4? 1. We could have also just written this as 13 because that means the same thing. Okay, let's continue on to the next slide. All right, so our new learning here is that if two numbers are written in exponential notation, so say we have 6 to the second and 6 to the first, and we're dividing them, we simply subtract the exponents. 2 take away 1, this is the same as 6 to the first. Okay, that is our new learning for dividing numbers that have the same base. Let's continue with this new learning. All right, so if these are just variables and not actual numbers, same rule applies, right? We're doing AB to the ninth divided by AB to the second, sorry, A over B. This is the same as saying A over B to the, what's 9 take away 2? 7th, okay? Do the one on the bottom. And you should have got that this answer is x to the first power, and x to the first power reduces to just be x. Remember, anything to the first power is just one of them, so it's just itself. Let's keep going. All right, so let's look at these a little bit closer together. So for exercise 27, what they did is they said, okay, we have 2 to the 7th over 4 to the second. And they said, you know what, I can take this 4 to the second and I can turn this into a base of 2. So 4 to the second, 4 times 4 is the same as 2 to the fourth. 2 times 2 times 2 times 2. Okay, so now that these have the same base, we can actually make this a lot simpler. So 2 to the 7th over 2 to the 4th, this is the same as 2 to the 7, take away 4, third. Okay, moving on to exercise 28. They did the same thing here. They said I have 3 to the 23rd over 27. And they said, well, you know what? I can turn 27 into a base that has 3 so that then I can actually simplify this. So they kept this 3 to the 23rd on top, and they turned this 27. 27 is the same as 3 to the third power, 3 cubed. Okay? From there, they solved it. 23 take away 3. This is 20. All right. 29 and 30, these are combining multiplication with division. So we're just going to break this up. The first part that we're going to do is we're going to simplify these. So 3 to the 5th divided by 3 to the second. This is the same as 3 to the third. Okay. 2 to the 8th over 2 to the third. This is the same as 2 to the 5th because we just subtract. And we are multiplying these both together. Okay. And that's as simple as we can make it because we cannot combine a 2 and a 3. Those are not the same base. Okay. Moving into number 30. For this first one, we can definitely simplify that. Negative 2, and we're doing 7 take away 5. This becomes a 2. And we're multiplying this by this right here. We have 95. And we're doing 5 take away 4. This is just a 1. So I'm just honestly going to leave it as 95. I'm not even going to put the 1. Okay? I don't even need to do that. All right. Make sure you have those down. And then we will continue on. All right, we're actually going to skip this number and skip this slide for the time being. We'll come back to this learning at another time. Okay? Here's our lesson summary for today. If two numbers are written in exponential notation and they have the same base and they're being multiplied, we can just add those exponents together. Okay? Additionally, if two numbers are written in the same in exponential notation, they have the same base and they're being divided, we can just subtract those exponents. All right, that's our new learning for today. Hopefully you understand this rule and you'll be able to apply it in our exit ticket. Let's go over our exit ticket right now. All right, here's your exit ticket for today. It says let A and B be positive integers. What would this come out to be if you were to simplify that? Number 2, one thing I do want to point out to you is that 5 to the second power is the same as 25. So essentially this is the same as saying that. You might want to write that down because that makes it a lot easier for you. Number 3, simplify this. How would we write this? And then number 4, you're going to be doing the same thing, dividing these. These are all in Galileo, and they are multiple choice, so please head over to Galileo and complete this. And when you're done, please do your reflection as well.